Alrighty, my friends, we are going to go ahead and take a look at a different form of a quadratic. Quadratic is still just going to mean that you have an x squared term, and when you have an x squared term, it's going to be a parabola. So this one's just going to look different in terms of how it's written. Just like when we did linear, we had standard form, we had mx plus b. This is just a different form, and it's called vertex form for a reason, because you're able to tell the vertex just by looking at the equation. So here's what that format looks like. Y equals, you're still going to have an A out in front, and it's still important and true that if you have a positive A, it will open up, a negative A will open down. So that's called A because it means the same thing as in standard form. Inside these parentheses, you're going to have a number. And then on the outside, you're going to have a number. This looks really similar to what we did with absolute value. And the reason these are not B's and C's is they don't tell you the same information as the B and C in standard form. What you can tell is the vertex just by looking at it, and that is why it's called vertex form. These two things will tell you the vertex just like they did with absolute value, and also just like the absolute value, when you look at this one, the x part is going to be the opposite of what's inside the parentheses. So the opposite of h, and then k as is. So if you remember when we did absolute value, you would change the sign of the number that was inside the bars. You're going to do the same thing here and change the sign of the number that's inside the parentheses. So now that I know my vertex, the axis or line of symmetry still has to go down through that, and it's still a vertical line. So it's going to be x equals whatever that opposite of h was, because x is always going to have to go through the x part of your vertex. So just like we talked about with standard form, your axis of symmetry has to be an x equals equation. Your vertex is going to be a coordinate pair because you have the x part of the vertex and the y part of the vertex. So when we go to do graphing, let's go ahead, figure out the vertex. And in this case, it's just an eyeball activity. Since I see a positive 3 inside the parentheses, I'll use negative 3, and then I use the 1 on the outside as it appears. So at negative 1, 2, 3, 1, that's going to be the vertex. My A value is a positive 1/4. So one thing I know is that because it's positive, it's going to open up. And then another thing I know because it's 1/4 is that it's going to be wide, because just again, like the absolute value graphs, it's not going up as fast because it's a smaller number. So then what I'm going to do is I am going to determine my axis of symmetry. So now that I know my vertex, I can find my axis of symmetry with, again, no math. It's a vertical line, x equals, and I just take the x part of the coordinate, the x coordinate of the vertex, because I need it to go down through there, so it has to be located at the same place as my vertex. Then one thing that is different, I'm supposed to find my y-intercept, keeping in mind that that is the y value when the x value is 0. So this, unlike standard form, I actually have to do math to figure it out. It's not just a number that I see in the equation, because here the 0 doesn't cancel stuff out. 0 plus 3 is 3. PEMDAS is still real, so then that's going to turn into a 9, and then I'm going to add 1. You can definitely use your calculator for this, and when you're done, you get 3.25. So my y-intercept is going to be at 0, 1, 2, 3, and a quarter. And so since that is 1, 2, 3 units to the right of my axis of symmetry, then 1, 2, 3 units to the left would also be at 3.25. And then I can kind of draw through here, and I'm getting, whoops, that's not very great. Please make a correction, thank you. I'm getting a parabola that is indeed opening up and wide, has a vertex at that spot. Okay, let's try the same here. Kind of think about what you know going into it. What I know going into it is that my A is negative 3. So because it's negative, I know it's going to open down because I have a negative A. I also know that this one's going to be more narrow because the actual value of my A is a 3, which is greater than 1, so it's going to go up faster than normal. I can identify my vertex in vertex form pretty easily, opposite of the number inside the parentheses and then the number that's on the outside of the parentheses. So at 2, up 1, 2, 3, 4, 5, 6, 7, 8, I have my vertex. My axis of symmetry or line of symmetry is a vertical line that goes down through that. So X would have to be located at 2, and then that way my line of symmetry will come down through, located where it needs to be to hit that vertex. When I want to find my y-intercept, I'm going to plug in a 0. And again, 0 minus 2 is negative 2. But when I square negative 2, I get a positive 4. And so I end up with negative 12 plus 8. So I'm going to have 0, negative 4 as my y-intercept. So 0 down 1, 2, 3, 4. That's 2 to the left, so 2 to the right. I'm going to have the same point, same y value. So it's going to come up, hit that vertex, come back down. And again, kind of going into it knowing, whoa, help. Good enough. Knowing what to expect, it does have a vertex at 2, 8. The axis of symmetry comes down at x equals 2. It is opening down. It is narrow. So everything kind of matches what I expected to see. Okay, so here we're going to be giving information, but without having to graph it. So think about whether it opens up or down. That's looking at the A. A negative A is going to make it open down. So think about what you look at in each case. So in this case, I have a negative A. The vertex, well, this is in vertex form. So I take the number from the inside of parentheses and change it. I keep the number on the outside of parentheses. To find my axis of symmetry, I write x equal to the vertex x coordinate. So x would have to go through negative 2. My y-intercept, I actually have to do a little bit of math. So you can use your calculator, and if you type this in exactly as you see it, it's going to go ahead and help you find that. And you remember, you always want to write that as 0 and then a number. This one is going to be an x coordinate and a y coordinate. So will it be wider, narrower, or the same? Well, the absolute value of my A is 3, which is greater than 1. So it's going to be going steeper, faster. And so this one is going to be narrow. So you can know all of that without actually having to graph it. Now watch, this one is in standard form. So I have to kind of think about what does that look like. So here my A is 2, my B is negative 4, my C is 5. So opening up or down is still just looking at A. I have a positive A, so that's going to make it open up. My vertex is a little trickier. I have to take the opposite of my B over 2 times my A. Sorry, my A is not negative. So I end up with 4 over 4. So the x-coordinate of my vertex is just going to be a 1. But once I know that, I can go back up into my equation and plug in a 1 to find what y value would go with that. So the y-coordinate of my vertex will turn out to be a 3 when you run that through your calculator or your brain. Line of symmetry, never have to do any math. X equals, and then it has to go through that x coordinate of the vertex. And in standard form, if you remember, when you plug in a 0, all of these first parts disappear and you're just left with the C value. Here, to look at my A value is 2. 2 is greater than 1, so it will go steeper faster, and that will make it narrower than a normal or average parent graph. So you can get all the information, whether it's in standard form or vertex form, and you can recognize vertex form pretty easily because it has the parenthesis part squared, whereas this one is written out like a full polynomial. So how do you go back and forth? Basically, we're just going to do a little bit of algebra and say, hey, what do I need to do? Here are the steps that usually are going to get us from vertex to standard. First, you're going to FOIL the parentheses squared part, and then you're going to distribute whatever your A value is, and then last, you're going to combine any like terms. And you may not end up having to do all these steps, but this one has all three of them, so let's do that. So PEMDAS is real, it always is, and so because of that, we have to do the exponent first. So that's why this part has to be done. So I'm going to take x minus 1 and multiply it by itself using FOIL. So I'm going to do the first, I'm going to let the 4 just chill out in front. First times first, this is the outside, the inside, and here the negatives cancel out. So I end up with a 4, oops, sorry, that should have been squared, x squared, and then these two are a minus 2x together, plus 1, and then plus 9. Okay, now I'm going to distribute that a because now I'm moving on to multiplication. So this 4 is going to multiply by all of those, giving me 4x squared minus 8x plus 4, and then I still have that plus 9 hanging at the end. So when I'm done, my new function, and I'm going to write it in function notation, is 4x squared minus 8x, but I still have to do this last step of combining terms, which is just putting these two numbers together. So this parabola is the exact same one that I started with up here. This one and this one are identical. It's just one is written in standard form and one is written in vertex form. Okay, so then you guys have to, and again, you have to go to 4.2 day 3. I do that all the time, sorry guys. So if you go to 4.2 day 3 in your packet, you're gonna find the word problem that it applies to what we're doing right now. And so that's gonna be this guy, this bridge. And really what I'm concerned about is this. I look at this and I say, oh, this is in vertex form, and I can tell because it's got that parentheses part squared. So no matter what it's about, I can answer the questions knowing vertex form and how to find information. So it's talking about the Tacoma Narrows Bridge in Washington. It has 2 support towers that each rise 307 feet above the roadway, which you can see in the picture. They're connected by suspension cables. Each cable length, which would be like how high it is, can be modeled by this function. Okay, so what is the height of the shortest cable? Keep in mind that we have a parabola following along the top of this bridge. So the shortest one is going to be smack dab right here at the minimum. So they're asking you for the minimum, but you want the actual value of it. And so they're asking for the y part of the vertex. Because if you think of this as your origin over here, you're going to be going over and then up to get to that vertex. Well, this is in vertex form. So if you look at this equation, the vertex is going to be at positive 1400, because that's the opposite of what's inside, and then 27. What does that mean in my picture? It means that from here to here is 1400 feet, and that this cable, the shortest one, is 27 feet high. So the question is, what is the height of the shortest cable? And the answer is 27 feet. So even though the problem looks really terrifying, it's just asking me for the things that I already know how to find. What is the distance between the 2 towers? Okay, so we're going to use our big brain. If that vertex is halfway, and that's 1400, then the other half must be 1400 as well. And so I'm simply going to double that distance to the middle and say, well, all the way across the bridge must be 2800 feet. So again, you look at this equation and you might be like, that is way more than I can manage, but I didn't do any math and I didn't need a calculator. I just had to use my understanding of what the parts of the equation mean. So now you're basically an expert on vertex form. I will make a video for filling in that part of the quadratics chart as well.